Hello, I'm Ryan, Content Manager here at Optigo Networks. We're doing things a little bit different this week as Ping and I go through the results of our newly released 2025 State of the Network report. It's a great discussion, so we hope you'll stick around. Hello, welcome back, and Happy New Year, Ping.
Happy New Year, Ryan.
So we're here today to talk about our new 2025 State of the Network report from Optigo. It's the first one we've done. We're really excited about this. And I guess the first thing we'll tell viewers, what was the reason to put this together when this is the time of year when everybody else puts out some kind of a State of the Network, state of our business report? Why did we decide we wanted to start adding to those?
Full transparency, we weren't really planning to do it. We were doing some analysis of our own system to understand how the year went and how the system has grown, and what our users are doing with the system. And a lot of people in the company found this information very, very interesting. And that's when you and I thought, hey, let's make this public. So that's the first thing. And then when we thought this could be fun to do, I think we realized that we're in a unique position. I don't think there's a lot of organizations out there that would have access to this information, to the data of real OT networks, and especially from a multi-vendor point of view. We are not associated with any major OEM of building automation vendors. And so we have this ability to kind of look at it from a little bit more agnostic point of view. And of course, we do get asked, right? We have friends in the industry that ask us, do you see this? Do you see that? How often do you see who is? And how often do you see broadcast storms and things like that? So yeah, we thought this would be kind of fun to put together.
And one of the other things that's really great about this is that now that we've established this baseline, it'll make future iterations of this very exciting. And now we can start tracking any shifts that we see, and hopefully that's reflective of overall moves within the industry, right?
Yeah, that's right.
And speaking of, let's see if we can't just pull this report up here, because as much fun as it is to look at our faces, let's show people what we're here for. So here we go. We can start here. For anybody who hasn't seen this yet, this is now published and available on our website at optigo.net. It's the latest blog entry. I'll be sure to drop links in any of the comments if you're watching this on our YouTube channel. So our executive summary, let's jump right into it. Some of the things that we saw, some of the themes that really carried over for the whole thing, these ideas of scaling complexity in OT networks, maybe not a huge surprise to a lot of people, but the majority of our networks we found are still very much a hybrid mix of MSTP and BACnet IP, and a very interesting mix of network health scores. We'll talk more on that in just a few minutes. Yeah, just going through this executive summary, is there any big themes that you think you might want to talk about or mention here?
I think I should start with a disclaimer. The information we gathered ourselves, it is based out of one of our server. We have a few other servers. We have customers, still a lot of customers on Visual BACnet. We'll be migrating over to Optical Visual Networks shortly. We have some customers that have their own system, and we did not pull that information from there. So this is from the multi-tenant Optical Visual Networks server. So let's start with that. I think overall, I wasn't really surprised with the information. It gave quantifiable information around it. But I mean, I do get the chance to work with this every day. And what I mean by that is that I do see every day, and this is what this report is showing, that there's an over-reliance on polling, on reading of data. There's a strong correlation between the amount of traffic and the performance of the system.
And I think in some of the further slides, we're going to see that's kind of going to get bared out. I know that we were all really surprised to see some of these figures that we see here. Big jumps, obviously, in data processed. And I know you were quite excited to see so much action with the meat and potatoes of what we do, the PCAP file uploads. So I'll let you sort of talk about a couple of these points here.
Yeah, I think the 22.5 terabyte of data that was processed this year is a little scary. Just confirm what some of our engineers were saying, right? Our system is very, very well used, and it continues to grow. That was a pretty cool number to put forward. I think, Ryan, you did a little research and compared it to, I think, like Wikipedia.
Yes. Yeah, I think we've got it in that little pop out for context there. I think the total size of English Wikipedia, excluding any of the videos and stuff, is about 24 gigs. So this is on the order of, I don't know, I'm not a math professional, but what is this, like 1,000 times more data we handled, our little company, compared to a massive database like Wikipedia. So absolutely incredible. From the non-technical sort of standpoint, for me, what this really showed me is a lot of our clients are really starting to embrace using Optigo VN and using just a solution in general on a more regular basis. And we really do try to emphasize that it's a great time now to start moving away from sort of a break fix. And some of these results really show that. For 2,000 plus networks to be uploading over 1 million PCAP files shows you people are really starting to use this on a regular basis.
I think what you mentioned there very briefly is very important to point out, is that our user base are becoming more sophisticated. They're really moving from using optical vision networks to troubleshoot a one-time problem, into monitoring, into continuous use, into validation of change in the system. That's why we're seeing this increase in number of files, even faster than the number of increase in users and increase in number of networks.
Yep, yep, it's amazing.
I like surprised me a little bit was this network complexity, the size of networks. I
Yeah,
thought an average network, if we took all the networks and averaged it out, I thought we were closer to like 300, 400 devices. So it's pretty cool to see like that the average number of devices is almost 800 devices.
right.
And for those who are wondering, we count device by device ID. So anything that has a BACnet device ID is considered a BACnet MSTP, BACnet IP, BACnet Ethernet. Anything that has a BACnet identifier, BACnet instance number.
And moving on here quickly to, this is our, what we're calling our growth and engagement. And this is very much focused on, like we were saying, the increased activity that we're seeing amongst our customers, which is, again, hopefully indicative of what's happening across the entire industry. And like you saw here, it was and just a huge jump, literally a doubling of traffic between 2024 and 2025 of people actively processing PCAP files, as you can see, from 400,000 to over 1.1 million PCAP files. I think this was a milestone for us. We crossed 1 million PCAP uploads for the first time, sometime in Q3, bringing new networks online. And from what we've seen, these networks are, a combination of new customers, but also customers we found expanding their existing footprints. So people were in 2024 maybe testing the waters with a couple of their networks. But now we see a lot of our customers that we have really great relationships are really coming all in and really migrating a lot of their systems to be monitored on a regular basis. Is that right?
Yep, 100%. Yeah, we are seeing one point of data that doesn't show here is the number of networks that have a continuous upload or multiple uploads per week. It's a far higher ratio
That's
again.
right. Which again is also something we love to see is people doing continuous uploading, right, and moving to a state of constant vigilance and deep visibility for their networks.
Yeah, I think people are understanding that instead of looking for a problem when the problem has occurred, monitor the system so that you can get ahead of it, stay ahead of the problem, or at least when the problem does show up, you have the data to back up to analyze.
Right. One of the ones I think that's been a good question, a spicy question for us, as well as I believe probably around the industry, that we see bored out in the network composition. Is MSTP still matter? That was one of our most commented on, I believe, articles of 2025. This is MSTP still part of your mix? Is MSTP still important? Should people still be using it? Well, according to our customers, very much so.
Yeah,
I'll let you break this down for people.
I think it's really important to point out that this is, again, is taking a snapshot of what exists in the world connected to optical vision networks, not what's being sold, right? So this is not new sales. This is what's used, what's installed. So perhaps a concept, the idea that MSTP is going away might be from a new perspective, new bill, new sales. But as you can tell, I mean, BACnet systems easily run for 10, 20 years. There's still a huge dominance in MSTP serial connected BACnet devices. I should point out that the terminology here, MSTP, does include ArcNet for those who have ArcNet in there. Without going into detail, it's almost impossible to distinguish between ArcNet and MSTP once it gets routed.
There you go. So ArcNet users who are still out there, you've been captured as well.
Yes, that's right.
And I think that this is a really good one to sort of dive into here. Global response times. So first of all, what are people seeing here in this graph? What does this represent? And then what really jumps out for you about these global response times?
Great. Yeah, so keep in mind again, this global response time was a snapshot over a couple of days, I think, of data. So it doesn't take the entire year, but I think those couple of days should be pretty representative of the entire market that we do get to observe. We should expect the first two bars. The first two bars showing you that the majority of responses of communication, two-way communication, when you send a read and you get a response back, when you send a write, you get an okay back. But the majority of them are fairly quick, right? Below 200 milliseconds. That's what we expect.
That's just the nature of packets for OT networking to travel. This would be the default range.
That's right. That is definitely default range. I will say that I expected the spike on the first bar to be even higher than the second bar. The fact that there's still a fairly high ratio of response time between 100 to 200 millisecond, that's even higher than expected still. And I would suspect that majority of that is communication that gets routed through a BACnet router of some sort. But just put it in perspective, this conversation that Ryan and I are having right now over the internet, we're having a 10 to 20 millisecond of delay of my voice getting to Ryan. So the fact that in BACnet systems is taking more than 100 milliseconds, that's quite a bit more than a normal video call or
Right.
internet traffic. But it's still reasonable in building automation systems. What I
Absolutely.
did not expect to see was that second last bump, that second modal, we call it, the one around the 1 to 2 second of 2 million response time in the 1 to 2 seconds. So it is showing that there are systems out there that have fairly significant delays. And even all the other ones, they're not insignificant. We're saying that if you add this all up, there's still a fairly high ratio of systems that have delays, over 200 milliseconds. And that's problematic, right? That's you wanting to read something and having to wait over 200 milliseconds for the response to come back. Wanting to do an override and waiting for that to come back. Thinking about balancing in your HVAC systems. If something expects a fan to turn on before something happens, there's that delay. That's probably not expected. 200 milliseconds probably is reasonable and acceptable, but you can see that ratio as you push it to the right is still not insignificant.
I was going to say where you said that sort of unexpected spike at 1 to 2 seconds, those would probably be where issues are lying for people, right?
Oh, absolutely. Yeah. That's when this is noticeable as a human, right? You're refreshing your graphics. It's taking time to come back. Your commands are taking longer than expected. But keep in mind also, once you get north of 2 seconds, in that 6 second range, you're starting to run into those timeout limits.
Right.
That's problematic.
That would do it.
So I think this graph is just showing you is a strong representation of system performance. So again, the majority of system is working quite well, but it's not an insignificant ratio of systems that are slow. That's exactly what this is showing.
Right. And I think we can really sort of drill down into that. And I thought that this is probably one of the most interesting ones I would think for viewers right now, because these sort of give you the opportunity to compare yourself to everybody else, because these are the breakdowns we saw across everyone from small sort of, singular or one or two little networks up to huge campuses.
Huge ones. Yeah. Huge campus.
So I'll let you sort of dive into these and let people know what we're looking at here. The traffic breakdown and I think the next one that we'll talk about sort of the most common errors we saw are really the most interesting ones and tell the story really well.
Yeah. Before I dive into the packet distribution, if anyone here really wants to dive into this detail, wants to see the detailed information, reach out to Ryan, reach out to myself, and we can definitely share this information in more detail. But here's a breakdown of the packet types that we saw in the system. And again, we're talking about a snapshot over a couple of days. We didn't take the entire year. That would be way too much compute. But it should be fairly representative of the systems out there. I wasn't super surprised to see that 60% of the packets that we see in our systems are reads, read property multiple, for those who are wondering. And that's not surprising, right? The majority of building automation is about reading points, is about create a historian of your data, and any analytics platform will read the data before you can make some business intelligence insights out of it. So it is showing that is a fact. But I think one thing that, this was also pointing out, as Ryan mentioned earlier, is that there's actually a very small ratio of data collection using change of value, of using a
Yes.
push approach. It's also inferring that we're likely reading more than we need to. So if you're reading, for example, an indoor temperature and you're reading it every 5 seconds, is that really necessary? You're using resources, network resources, compute resources, storage resources unnecessarily. So I think that's probably the biggest message here, is that
Right.
we're overly reliant on these reads.
And I think it might be important to clarify as well, is that if your packet breakdown is looking like this with a lot of data polling, that's not necessarily a bad thing. This isn't an indication that you're way off the mark and that you need to stop what you're doing, right? Like you said, this is a lot of the nature of the work OT
Yes,
does.
yes,
What we found is there's a lot of opportunity perhaps to make it more efficient.
that's right. That's right.
Yeah.
Yeah, exactly. Second, I would point out this discovery who is.
Yeah.
These are just the who is, by the way. That's a big ratio, and that's wasted traffic. And
Great.
by the way, almost all of these would be broadcasted who is. So that's going everywhere in your network, including through your BACnet routers into the MSTP networks. And you'll see shortly, when we look at the most common diagnostic issues we found, that one is what we call unreachable devices. Those are devices that no longer exist, but your database still includes them. And so your server, your devices has to look for them. And that's
Mhm.
waste traffic. That is definitely a low-hanging fruit that you can benefit from cleaning up.
And so I have a question for you, and this was one that was interesting to me, is that was identified these 11% as proprietary or vendor messages. Do you have any insights on what those might be?
Yeah, I mean, they're typically what we call private transfers, and they're used for many reasons. They are used for loading graphics, they're used for updating software, they're used for loading schedules, things like that. Typically, it is sign of something not working correctly. I'm thinking of one example, a large example, where there was a network that couldn't communicate with another network, and the fallback behavior was to broadcast using these unconfirmed private transfers, and is doing a very high rate. But yeah, it is showing that these proprietary, vendor specific BACnet messages do exist.
Hmm.
They are a collection of many different things, but it is more than we should see.
Our next one here is vendors and platforms. I know that these sometimes have a lot of interest to people who particularly are in the procurement area for hardware.
Yeah, I would certainly advise against using this information to decide who to buy from. But again, this is not a snapshot of what is being sold today. This is a snapshot of what is already installed, right? Just keep that in mind. I should definitely point out, for those who are wondering why Honeywell has such a big piece here,
Mhm.
Honeywell here is combining multiple brands.
That's
Okay,
right.
so Allerton, Honeywell, Trend, right? So to keep
Yeah.
that in mind, even
Yeah.
Tritium sometimes might fall into Honeywell here.
That's right. Yeah.
I think the most interesting thing of this page here, this part here, is the others. Really neat, yeah. I really enjoy looking at the bottom part of the list, seeing a lighting control becoming more and more relevant and
Yep.
noticeable in terms of
Yep.
the number of devices. I think, Ryan, you and I, when we were looking at the data, we saw like a couple of elevators. It was kind of
That's right.
cool.
That's
Yeah.
right. Yeah, I find it so interesting to see how and you'll probably have more insight through your experience, this idea of sort of the mixed environments start to become more prevalent, popping up more often, and essentially becoming more integrated across IP systems. I thought it was really interesting to see that convergence of all of the sort of automation components of smart buildings
Yeah.
running through these networks.
And this is, I mean, a big kudos, a big testimonial to the BACnet community for getting an open, interoperable platform. This is, again, when you look at this full list, which you don't have access to, but we did, and you can look at the others, this is interoperability. This is an open
Yep.
system allowing you to buy products from multiple vendors, integrating them into a single system. Very, very, very powerful.
I think we have the one that we're sort of all very interested in here was the network health and troubleshooting. I was surprised to see an almost 30-30-30 split between and we should say, I think, Ping, we deem a healthy network to be at 80% or above on our Optigo VN network health score, right? So what we're seeing here is, yeah, a pretty even split. And obviously, that's tied very closely to what we saw as our top 5 diagnostic issues. And just in case if this is too light for you to see on the screen, number one is what we call the programming errors or unknown errors of a programming type, followed by unreachable devices, unacknowledged requests, and then excessive read rate and broadcast traffic rate. I think I'd be surprised if those two weren't in there at this point.
Right.
But
Yeah.
yeah, why don't you give us a little bit of insights into this? First of all, are you surprised by any of these?
I'll be honest, I didn't know what to expect from a score distribution. Of course, I get brought in most of the time in the yellow and red zone. I know for sure there's lots of green. So the customers have been using our product, cleaning up things, and then keeping it there, monitoring it, make sure that doesn't degrade. I didn't know what to expect. It's pretty neat to be able to see that on in a chart, a simple chart. It is showing that there's all types. I mean, there's systems working well. They still choose to use a product, likely because they want to make sure that their system continue working well, or it wasn't working well. They fixed some stuff, cleaned it up, got it to the green, validated that, and then of course red and yellow needs work. Yeah. In terms of the top diagnostic issues, let me mention a little bit, first of all, on the programming errors. We are a software company. We hate to admit it, but there's always improvements available. Programming errors on its own does mean that a device is looking for another device or looking for a point or object that does not exist. However, we did discover that that is used commonly as a mechanism to discover whether an object or a property exists. So we need to tune our diagnostics a little bit to be able to account for these auto discovery, let's call them, and not true human errors where you wrote a program, wrote a sequence, and now referring to the wrong point, wrong object, wrong device.
Right. Sorry, I was going to say, even in its current state, it still provides a good flag for you to investigate.
Yes, it's a very important flag. If you do go through the list and you are seeing something you did not expect there, then that's definitely something to clean up. Imagine if you're reading the temperature of water to make a decision and that point doesn't exist, your program is probably relying on a default value, which is uh, unlikely to be the correct value. And so the rest of the decisions are made on that incorrect default value. But right of all the other bars, unreachable devices, I mentioned that earlier, not surprised to see that. That just means, again, devices that did exist were removed or decommissioned, but other parts of the system is still referring to it and it's causing these unnecessary whois, which are broadcasted, takes a lot of resources in your system. Easy cleanup. You can take some time to clean that up in your system and reduce that unnecessary resource in your system.
Yeah, and it's something I didn't know or didn't quite understand, when I first started learning about OT networking, and the idea of some of these, polls and broadcasts and unreachable devices. These are going to be issues that can layer or combine, and they're not going to go away. They don't resolve themselves,
They don't.
right?
No,
There's
no,
no point where the table just gets updated on its own to drop things that aren't there anymore.
that's right. That's right. The other ones, they're all strong indicators of performance issues, by the way, right? Unacknowledged request, that's a drop packet. It's sending a request and not getting a response back. That's problematic. That's a sign that there's a bottleneck somewhere and the request didn't get there, or it got there and took too long to come back. Excessive read. Well, I mean, again, strong correlation we saw earlier, a strong reliance on read properties, on reading instead of reading less often, right? Or relying on other methods to collect data, such as a change of value, which
Right.
again does have its own issues. But you can see here, there's a lot of cases where optical visual networks has identified that a single object, a single point, is being read more often than every 5 minutes. That's what this definition is here, by
Yeah,
the way.
that's a good. Yeah, a good way to interpret it is these are a lot of these are also not only are they potential failure points, but they're also potential points for you to optimize your network, which is what makes running these PCAPs on a regular basis, so effective.
That's right. Yeah, and I should also add that these are fairly easy things to
Mm-hmm.
train everyone that's using that's working with building automation systems, BACnet systems, to read optical vision networks to see, oh, hey, I have excessive read rate. Let me look at what object is reading by who and verify if my polling policy is set incorrectly.
Right.
Or am I even reading this point that I need? Do I even need this point? Right. So this is again, diagnostics are fairly easy to read, fairly easy to address, and it has a direct impact on the health and the performance of your system. No, we shouldn't skip over the broadcast traffic rate. That one is well
Oh,
understood.
right.
Too much
Yes.
broadcast, too much noise. And again, you can kind of, the unreachable device is a strong correlation with broadcast traffic rate. If you're sending out who is that you don't need, it's going to create broadcast traffic. But broadcast traffic can be also other things, such as who has, it can be unconfirmed change of value. It can be lots and lots of different broadcast type of messages. But broadcast messages are direct problems to performance of systems.
Right. And I think perhaps this is something maybe you can shine a little light on too, is that some of these are also tuned based on our own thresholds that based on tons of experience and actual measurements. It goes back to the idea that broadcast traffic isn't necessarily a bad thing unless it's out of control.
That's the core. That's the relationship between a score and a diagnostic, right? Optical visual networks might highlight a diagnostic as red, but if your score is 93%, well, the impact is not so significant that's really truly impacting the performance of your overall system.
Hmm.
Whereas if you have a whole bunch of small diagnostics all scoring that yellow range, but your score is red, well, the cumulative effect of everything has a strong impact on your systems. To add to what Ryan is saying there, we create our own thresholds, but these are thresholds that we created over years and years of experience, years and years of consulting with experts in the market. We reached out to lots of people we believe are experts and asked them questions like, what do you deem as an excessive read rate?
Hmm.
How often do you think a COV should happen? What is the right way of using a device discovery? Who is and IAMs? So we write our diagnostics based on these best practices and to provide the best insights possible to our users.
Excellent. Overall, any feelings overall about some of the results we saw this year for 2025? Knowing it's our benchmark year, anything that was the big takeaway for you going forward into 26?
Yeah, super fun to do. Lots of great information. I would like to do it more often. I think this information is very, very valuable to many people. So again, I'll put out the offer. If you want to see more detail, reach out. I'm happy to share a little bit more detail. Anonymized. All this information is anonymized.
Oh, yes, yeah.
And I'm looking forward to seeing how it shifts in 2026.
Yes. I think that was two of the things we've sort of flagged here, and that was going to be my final question. What would you like to see now that we've done this the first time? What would you love to see next year? And this is obviously an open question to anybody watching as well. If there's any points that you would love us to try and dig up or to synthesize, this is Ping loves this stuff. It's a reason why fun fact, I wanted to call this show Ping Times. Oh, he's the man when it comes to diving into the ones and zeros. So is there anything you'd love to see us be able to add?
Yeah, first of all, as I mentioned, I really want to see how things are shifting. And that shift might not be very obvious over a short period of time. But if we continue to do this over a couple of years, are we seeing a shift, say, in the number of device by type, by MSTP, BACnet IP? Are we seeing a change in the vendor profile? Are we seeing a shift in the score profile? Another thing I would like to add to these reports is a little bit more correlation. Are we seeing a correlation between response time and the number of devices? Are we seeing a correlation between the number of devices and the amount of traffic? I think it'll be really, really interesting. And then how do we leverage this information to make everyone better? How can we help our customers get their system up running perfectly?
That's it for us. Thanks a lot, Ping, and thank you to everybody who watched. Please, optigo.net/state of the network report. You can take a look at it yourself. Like Ping said, you can send us a message, info@optigo.net, marketing@optigo.net. You can leave us a message on LinkedIn on our page there, or even on YouTube. We love your feedback because it helps us make all these reports better. So thanks again for joining us, and talk to you soon.
Bye. Thank you.
Bye.